We need to find the resistance RAB as seen from terminal A and B in this circuit. So here if we notice, we can see that there is a delta connection. This is one node, this is another node, and this is the third node of the delta. Now in order to simplify the resistance or find the equivalent resistance, we need to convert this delta into Y. So that's what I will do. I will draw the Y connection on top of this circuit instead of drawing it separately. So one Y will be here, one Y will be here, and one Y resistance will be here. So these are the three nodes where they will go. Now this Y value will be 30 times 20 divided by 30 plus 20 plus 12, sum of the three delta resistance, and multiplied in the numerator is the multiplication of the two resistance that were connected to this particular node where the Y is the new Y is connected. So 30 times 20 and divided by 62, we get 9.7. So that's there. Then I need to find this resistance, let's say. So we have the two delta resistances connected to this node are 30 ohms and 12 ohms. So 30 times 12 divided by sum of the three resistances, that is again 62, and the value we get is 5.8. so I will write 5.8 now like that. And finally we want to find the value of this resistance, which will be 20 times 12, because these two are connected in the delta to that node. So 20 times 12 divided by 62 again, and we get 3.9. so that will be 3.9 here. I don't know, maybe I will start erasing because I want to erase the delta resistances finally. So maybe I will do that. Let's erase that one, and that's 3.9 here, 3.9 ohms. And I want to erase the other deltas. This one is gone now. This is gone, this is gone. Sorry. So that's there, and then we have that. So that's 5.8. So that's what we have now. If we notice at this, if we leave it like that, we see that 5.8, of course we have to erase this one as well. So yeah, so all deltas are gone. So these are the Y's. So if I draw it more appropriately, or more, in a more standard way, let's say, what will be, I will actually leave it like that, so that's better. So 3.9 ohms and 60 ohms, these two are coming in series, as we can see now, and then that series combination is coming in parallel with the 5.8 resistor, 5.8 ohms. So I will erase this part which we needed for delta to Y conversion. We have already done the conversion, so I will erase that part. Now we have 5.8 parallel with 3.9 plus 60, that is 63.9. These two are in series. These two resistances are in series and coming in parallel with 5.8 ohms. So if we find the equivalent value of that 5.8, I have decided to erase and draw the resistances here in the original circuit instead of redrawing it again. So that's probably better. I don't know, I will just try this thing for this particular problem. So 5.8 times 63.9 divided by 5.8 plus 63.9, so we get 5.3. So if we go back here, we have to erase all these, and it will be just one resistance here. So this resistance will be gone as well. It will be now 5.3 ohms, and the 9.7, let's draw it like that now, 9.7 ohms. So we have now this 10 ohms, this 5.3 and 9.7 ohm, these three coming in series, and then the combination is coming in parallel with the 25 ohms. So 9.7 plus 5.3 plus 10 is 25, since these three are in series, so just 25 ohms. So I will remove that, 25 ohms. So that's now 25 ohms. And now we have these 25 ohms, these two are coming in parallel, so they are of equal value, so the equivalent will be half value, will be the half of this value, so that will be 12.5 ohms. So just one resistance now, 12.5 ohms. So the equivalent now becoming, this is an old thing, so the equivalent value finally RAB is now becoming 5 ohms. These three are in series, so 5 plus 15 plus 12.5, if we add them up, 5 plus 12.5, that is equals to RAB. So RAB is now 32.5 ohms. So that's the result.